In this short video, I'm going to evaluate and simplify the difference quotient shown here, f of x plus h minus f of x all over h. I'm going to do two examples. In the first example, f of x is defined as x squared plus 1, and we're going to evaluate and simplify f of x plus h minus f of x all over h. This expression is known as the difference quotient. It's used in calculus to define the derivative. To evaluate this quotient, we find f of x plus h and simplify it, and we plug it in. We also plug in the formula for f of x. F of x plus h is x plus h quantity squared plus 1. We FOIL out the x plus h and get x squared plus xh plus h squared. Then we add 1 to that, and what we get is x squared plus 2xh plus h squared plus 1. That's our f of x plus h. Now we just plug those results into our difference quotient. We plug in the x squared plus 2x plus h squared plus 1. We plug in the x squared plus 1. We put them all over h. Now what happens here is the x squared terms cancel each other and the 1's cancel, and all we're left with is 2xh plus h squared in the numerator. We can factor an h out of the numerator and then cancel that h with the h in the denominator, and what we're left with is 2x plus h. That's our simplified difference quotient. In our second example, our function is f of x equal x minus x squared, and we're going to find the difference quotient. The first thing you do is find f of x plus h. And f of x plus h is found by replacing x in our function with x plus h. So we get f of x plus h equal x plus h minus the quantity x plus h squared. Now we have to multiply out x plus h times x plus h. Well, that multiplies out to x squared plus 2xh plus h squared, and we have to remember to include those parentheses around all those terms. That's the most common error here, is to forget those parentheses. Now when we remove those parentheses, we find that the x squared turns into negative x squared, the 2xh turns into negative 2xh, and the h squared turns into negative h squared. We get a result of negative x squared plus x minus 2xh minus h squared plus h. Now we have to take that result and subtract f of x. And when we do that, we find that the x squares cancel each other. The x's also cancel each other, and what we're left with is just negative 2xh minus h squared plus h. That's the numerator of our difference quotient. We can plug that all in and put it all over h and then simplify it. So we get negative 2xh minus h squared plus h all over h, and then we can factor an h out, and then we can cancel out h's, and what we're left with is negative 2x minus h plus 1.